Welcome to Focus Math Plus, precision in every problem. Our classes are based on the latest CBSE Grade 9 Math syllabus aligned with the new NCERT textbook Ganita Manjari. So let's begin today's lesson on Chapter 1, which is about the introduction to the coordinate plane, and also let's discuss the questions from exercise 1.1. Let's begin with the introduction to the coordinate system. A Cartesian plane, also called as a coordinate plane or the xy plane, is a two-dimensional surface used to plot points and graph equations. It is formed by two perpendicular number lines, x and the y-axis, which intersect at the origin. Together, they allow us to locate any point using an ordered pair of numbers. The horizontal x-axis and the vertical y-axis both intersect at origin. The key components of the Cartesian plane: the horizontal x-axis, the values increase as you move towards the right, and the values decrease as you move towards the left. The vertical y-axis, the values increase as you move upwards, and the values decrease as you move downwards. The origin is the point where the x and the y-axis intersect, and the ordered pair here is 0, 0. Coordinates: the position of any point is represented by an ordered pair x, y, indicating its horizontal and vertical distance from the origin. The four quadrants. So the x-axis and the y-axis divide the Cartesian plane into four regions known as the quadrants. Quadrant 1, the upper right region, where both the x and the y values are positive. Quadrant 2, the upper left region, where the x values are negative and the y values are positive. Quadrant 3, the lower left region, where we have both the x and the y values to be negative. And then the quadrant 4, the lower right region, we have positive x values and negative y values. Ordered pair. Ordered pair is a pair of numbers wherein the first number belongs to the x-axis and it is called as the x-coordinate. The second number belonging to the y-axis and it is the y-coordinate. And if we were to plot this point on the coordinate plane, it will be 7 units to the right of the origin and 8 units downwards. And that's appearing in the fourth quadrant. Plotting points on the coordinate plane. Let's plot a few points. The first point, 3, 6. This point is located 3 units to the right of the origin and 6 units upwards in the first quadrant. The next point, negative 7, 9. It is 7 units to the left of the origin and 9 units upwards, and it is located in the second quadrant. The third point, negative 5, 4. It is 5 units to the left of the origin and 4 units downwards, located in the third quadrant. The fourth point, 2, negative 7. It is 2 units to the right of the origin and 7 units downwards in the fourth quadrant. The fifth point, 0, 5, is a point on the y-axis because the x-coordinate is 0. So it appears to be here on the y-axis. And the last one, 5, 0, is a point on the x-axis where the y-coordinate is 0. So 5, 0 is marked here. So any point on the x-axis wherein the y values is going to be 0, and any point on the y-axis, the x value is going to be 0. So let's start discussing the questions from exercise 1.1. So there is a figure given which shows Rayan's room with points O, A, B, C, marking its corners. The x and the y axis are marked in the figure. The point O is the origin. So you could see that the x axis and the y axis has been marked for our convenience. The first subdivision says if D1 and R1 represents the door of Rayan's room, how far is the door from the left wall of this room? And the next one is how far is the door from the x axis? So if this represents the coordinates of the door, so we've been asked how far is it from the x-axis. So because this door is placed on the x-axis, the distance is 0. The distance of the door from the x-axis is 0. But the coordinates, as we know that this is representing a point on the x-axis, and so this is 8, 0, and this point is already given, which is 11.5, 0. So when we were to see the distance of the first point from the left wall, because if this is going to be the right wall and the wall right opposite to is represented as the left wall, and this first point is 8 units away from the left wall, 5, 6, 7, and 8. So the door is at 8 units from the left wall, which is the y-axis. The next subdivision, you are to write the coordinates of D1, which is on the x-axis. Then obviously any point on the x-axis, the y-coordinate is going to be 0. So the coordinate of D1 are 8, 0, because the y values are 0. The third subdivision says if R1 is the point 11.5, 0, how wide is the door? So we have been given the 2 points, which is 8, 0 and 11.5, 0. We've been asked the width of this door. So we have to find out the horizontal distance. So it's 11.5 take away 8, which gives us 3.5. Now, if we were been given the scale that if one unit represents 1 foot, so then it's 3.5 feet, which is approximately equal to 42 inches, because 1 foot is 12 inches approximately. So which is a comfortable width for a room door. So this represents 3.5 units. And if we were to multiply 3.5 times 12, we get around 42. So this is a comfortable width for a room door. There's another subdivision wherein we have to mention if a person in a wheelchair wants to enter the room, well, he or she will be able to do so. So that's the next question. So as we've found that the width of the door is 3.5 units, which is around 42 inches, then what about a wheelchair passing through it? Would it be able to? That's the question. Let's check. For that, we have to know the standard width of the wheelchair. As we have found that the door width is 42 inches, which is quite comfortable width for a room door. And also the overall standard width of an adult wheelchair typically ranges from 24 to 27 inches. So which is much smaller when compared, because 27 is smaller than 42 inches. So hence it is quite comfortable and quite wide. So therefore the door width is sufficient for wheelchairs accessibility. This is the last part of the exercise wherein we are being given the 2 points B1 and B2. B1 represents the point 0, 1.5, and B2 represents 0, 4. So these represents the ends of the bathroom door. So we are to find, is the bathroom door narrower or wider than the room door? In the previous question, we found out that the width of the room door is 3.5 units, which was approximately equal to 42 inches. And now we need to find out the width of the bathroom door, and we need to check if it is narrower or wider. So because these points are located on the y-axis, the x-coordinates are 0. So if we have to find out the vertical distance, we subtract the y-coordinates. We subtract 1.5 from 4. So 4 take away 1.5 is 2.5 units. And as you could see, since 2.5 is less than 3.5, the bathroom door is narrower than the room door. So just drop your answers in the comments for the question, what is the x-coordinate of a point on the y-axis? Okay, and thanks for watching.